The goal of this video is to be able to find all zeros of the polynomial. So let's take a look at this one, 6x cubed plus 13x squared plus x minus 2. First of all, let's take a look. It may not be easy to factor, if at all. So how can we find zeros? Well, first of all, let us use possible zeros, rational zeros test. If the polynomial has a rational zero, it's going to be 1 in the list. So if you guys recall, the possible zeros of the polynomial is p over q. So how do we find p over q? Well, p, if you guys recall, are factors of the constant term. So any factors, which would be positive and negative actually, and if you notice 1 and 2 go into negative 2. So that would be our part for the numerator. Then we have the denominator, which means there would be the factors of 6, so positive or negative. So we know that 1, 2, 3, and 6 all go into the leading coefficient right here. So p over q are possible zeros, which are rational, so there would be integers or fractions. So what we're going to do is each p we're going to match with a q. So we're going to do, first of all, 1 and 2 would be over 1, which means would be plus or minus 1 comma 2. We'll start with integers. Then we have 1 over 2. That would be the next one. Then we have 2 over 2, which reduces to 1, so we already have it in the list, so we don't need to write it again. Then we have 1/3, so we keep going down the list. Then we have 2/3. Then we have 1/6, and then we have 2/6, but 2/6 actually gives us 1/3, which we already have on the list. So actually we are done. So let us conclude the list. So these are possible zeros, but we have too many. We know that the maximum zeros that this polynomial can have is the degree, which is 3 right here. So obviously it cannot be all these zeros. So how do we know which ones work? Well, we can either test all of them, but again, the polynomial may not have just rational zeros. So we may not be able to get all the zeros this way. But if we test the q, let's say we can do it in a couple of ways. We can either keep doing the synthetic division on the zeros, for example, positive 1, negative 1, positive 2, negative 2, and keep on going down until we get the first one that works. Or here is the handy factor theorem that if the number is a 0, then what would happen is that the polynomial, if we evaluate it at this number, would be 0 as well. Well, actually, I tested this already, and I recommend you guys do as well. The 1 actually doesn't work. Clearly, if we plug in 1, we're not going to get 0. Negative 1 doesn't work neither. Actually, the first one that works is actually negative 2. And I recommend you guys check this. So p of negative 2, if you plug it in for the x right here, would actually be 0. So, and we're going to check this with synthetic division. So how do we find the rest of the zeros? Let's take a look. Let's perform the synthetic division on this. That way we can get the remaining polynomial. So if we have negative 2, the way to do synthetic division, if we recall our polynomial was, let's take a look, 6x cubed plus 13x squared plus x minus 2. So we're going to use coefficients for synthetic division. So it's going to be 6, 13, 1, and negative 2. Make sure we account for each degree, but none of the degrees are missing, so this is what we have. So then we draw the line. So then how do we do synthetic division? Scroll down. We take the first coefficient, just comes down, so it's actually 6. And that one we do is we multiply negative 2 by 6, which is negative 12. Then we want to add the corresponding coefficients. So 13 plus negative 2 would be 1, and then we repeat the process. Negative 2 times 1 is negative 2. Again, we add the coefficients. So we're going to get negative 1. Negative 2 times negative 1 would actually be positive 2, and notice the last point that we get is 0, and that's usually the remainder. And this is what we want. If the remainder is 0, then we know we have a 0. So negative 2 is a 0. How do we find the rest of the zeros? Well, what we can do, usually this polynomial would be the one that we have right here divided by x minus 2. So we know the negative 2 is a factor. So how can we get this depressed polynomial? Well, it would be 1 degree less. So it should be 6x squared because it's 1 degree less from x cubed we have, plus 1x, or just x, and then we have minus 1. If you guys want, sometimes I work backwards. I start at the constant term, then the x, then x squared, and so on. And what we want to do is now we can find the zeros of this polynomial. Now with quadratic polynomials, it's a lot easier to find zeros because we can always factor them, or we can use quadratic formula. And that's typically what we can do. So I believe this one factors as, so we can try different things here. We can try 2x and 3x, for example. And notice to get positive 1 right here, we can try plus 1 and minus 1. So notice the outer term will actually be negative 2x, plus the inner term will be positive 3x. So altogether we're going to get x, which is what we want. So now we should set each part equal to 0, and we're going to get our zeros. So 2x plus 1 is equal to 0, or 3x minus 1 is equal to 0. So if we solve this one, we're going to get x equals to negative 1/2, which was also on the list, or x is equal to 1/3. And voila, we actually have all the three zeros, which is negative 2, negative 1/2, and 1/3. And we're done.